Hi, here's a small spreadsheet on exponentials. An exponential is a number raised to the power of another number. Here I've used the numbers in the x-axis. Looking at the formula, I've locked the formula on the green constant k with the dollar signs. Let's copy it across. Where x is negative, the value rises slowly to 1. Where x is 0, the value is 1 because any number raised to the power of 0 is 1. Where x is positive, the value increases quickly. Let's look at the opposite curve with the negative in the x there. So you can see it's the opposite shaped curve, and again where x is 0, y is 1. There are no negative results. That's because the minus sign in this formula means 1 over, not to put a negative sign in there. What's interesting is if we take this x-axis and square every number, they all become positive. And if we then put a minus sign in front of it, they all become negative. And we get an interesting shape that's very useful. Control C, Control V. So you can see the green line increases from very near the x-axis up to 1 and then back down again to the x-axis. It never touches the x-axis, it never crosses the x-axis, but we can measure the area under the curve. I've done that quite simply on the spreadsheet using the trapezium formula. It works very well, and you can see it's given an area for the green curve, under the green curve, of 3.45 square units. So if I increase that number to the value of e, which is 2.718, we can't see it because the other values are so large we can't see the detail. So I'll just delete these two lines. There we go. Now the area has decreased to 1.77. And what's interesting is that is the square root of pi. And a couple of hundred years ago, Gauss used that information to create this Gaussian curve, which is used for probability. But to do that, he wanted a probability or an area under the curve of 1. And that was done by dividing all the points of this curve by the square root of 2 pi. I've got a copy of that here. And there you can see it. That is the standard Gaussian curve that is used when the average is 0 and the standard deviation is 1. Another interesting thing about this is what happens if we put a negative number in this constant. That would change the green line. So I'll just put a minus sign in there. So now we're raising, or trying to raise, a minus number to each of the values along the x-axis. And you see we've lost the green curve. And that's because where the exponent is an integer, like -4, -3, -2, -1, 0, +1, and so on, the spreadsheet can calculate it because it uses real numbers. But in between it can't calculate it because we need imaginary numbers. This can be done in spreadsheets, but first it's a good idea to know what they mean. So I'm going to attach a diagram to the video at the end